Question 8, Part B. The diagram shows the graph of the parabola x squared equals 16y. The points A, 4, 1 and B, negative 8, 4 are on the parabola, and C is the point where the tangent to the parabola at A intersects the directrix. Part 1. Write down the equation of the directrix of the parabola x squared equals 16y. The equation of the parabola x squared equals 16y is in the form x squared equals 4ay, where a represents the focal length of the parabola, that is, the distance from the vertex to the focus or the distance from the vertex to the directrix. Hence, 4a equals 16, so we're equating the coefficient of y, which is 4a, and the coefficient of y here, which is 16. And solving this equation for a, we get a is equal to 4. So the focal length is 4, which means the distance from the vertex to the focus or to the directrix is 4 units. Now the parabola is concave up, with the vertex at the origin 0, 0. And the directrix is 4 units below the vertex. Therefore, the equation of the directrix is y equals negative 4. Part 2. Find the equation of the tangent to the parabola at the point A. Rearrange the equation of the parabola to make y the subject. So we get y is equal to 1 over 16 times x squared. Next, differentiate this equation to find the gradient function. So dy dx is equal to x over 8. Now at x equals 4, now this is the x coordinate of point A, the value of dy dx, which represents the gradient of the tangent at point A, is 1 over 2. So we have 4 over 8, which simplifies to 1 over 2. Now the equation of the tangent to the parabola at the point A with coordinates 4, 1 with gradient 1 over 2 is given by the point gradient formula. Y minus y1 equals m times x minus x1 in brackets, where x1 is 4, y1 is 1, and m is 1 over 2. Hence, y minus 1 equals 1 over 2 times x minus 4 in brackets. Multiplying both sides of the equation by the denominator 2, which eliminates this fraction here, we get 2y minus 2 equals x minus 4. And moving all terms on the left-hand side over to the right-hand side, we get 0 equals x minus 2y minus 2. Then we're going to switch the sides again, so that what's on the right-hand side is on the left and what's on the left is on the right. So we express the equation correctly in general form. We get the equation of the tangent is x minus 2y minus 2 equals 0. Part 3. Show that C is the point negative 6, negative 4. The tangent to the parabola with equation x minus 2y minus 2 equals 0 intersects with the directrix, which has equation y equals negative 4 at point C. That means the y coordinate of point C is negative 4, so we just need to find the x coordinate. Now the x coordinate of point C is found by solving x minus 2y minus 2 equals 0 for x, where y is equal to negative 4. So substituting negative 4 for y here and solving the equation, we have x minus 2 times negative 4 minus 2 equals 0. Now, negative 2 times negative 4 gives us positive 8. So the equation becomes x plus 8 minus 2 equals 0, which simplifies to x plus 6 equals 0. Therefore, x is equal to negative 6. Therefore, point C has coordinates negative 6, negative 4 as required. Part 4. Given that the equation of the line AB is y equals 2 minus x over 4, find the area bounded by the line AB and the parabola. We want the area bounded by the line y equals 2 minus x over 4 and the parabola y equals x squared over 16 between points A and B. Now the x-coordinate of point A is 4 and the x-coordinate of point B is negative 8. And those two values will form our limits of integration. Now I've indicated the shaded region with the capital letter R. So capital letter R is equal to the integral of 2 minus x over 4. That's our line minus x squared over 16, which is our parabola. Notice the order in which they're indicated. That's because between points A and B, the line is on or above the parabola, which is why the order is as so. Now to make the integration a little easier, I'm going to factorise out 1 over 16 from all three terms. So that way we don't have fractions inside the integral. So capital R is equal to 1 over 16 times the integral of 32 minus 4x minus x squared dx from x equals negative 8 to x equals 4. Performing the integration, we get 1 over 16 times 32x minus 2x squared minus x cubed over 3 from x equals negative 8 to x equals 4. Now, I need to be careful here applying the limits of integration because it involves a negative limit. Notice that we also have three terms that we need to contend with here. So applying the limits of integration, we get 1 over 16. Now, open bracket, we get 32 times 4 minus 2 times 4 squared minus 4 cubed over 3. And that's contained in its own set of brackets, minus 32 times negative 8 minus 2 times negative 8 in brackets squared. This set of brackets here is especially important because we're squaring a negative value, minus negative 8 in brackets cubed over 3. That's contained in its own set of brackets, and this is our outer bracket here, which corresponds to this bracket here. Now, after some simplification, eventually this evaluates to 18 if it's done correctly. Therefore, the area bounded by line AB and the parabola x squared equals 16y is 18 square units. Part 5. Hence or otherwise, find the shaded area bounded by the parabola, the tangent at A and the line BC. There's a variety of methods that we can use to find the area of the shaded region, and the method I'm going to employ here is to find the area of triangle ABC first using the formula half AB times sine C, and then subtract from that the area that we found in part 4. So that was the area bounded by the parabola and the line or the interval AB. So in order to find the area of triangle ABC, I need the length of AC and BC, but I also need the angle theta, so that's the included angle. Now to find angle theta, we need to find the angle of inclination of BC and then subtract from that the angle of inclination of AC. Let's have a look at the working out. So let theta equal the angle between AC and BC. Now theta is equal to the angle of inclination of BC minus the angle of inclination of AC. Let's call this equation number 1. Now the gradient of AC, using the 2-point formula, change in y divided by change in x, we get 1 over 2, and the gradient of BC, using the same formula, negative 4 minus 4 in brackets divided by negative 6 minus negative 8 in brackets, and that equals negative 4. Now from equation number 1, theta is equal to 180 degrees minus tan of positive 4. If you put tan of negative 4 in your calculator, you'll get a negative angle. So in order to correct for that, it's a quadrant 2 angle anyway, so it's 180 degrees minus the acute angle that's formed by the inverse tan of 4. And we minus from that inverse tan of 1 over 2. Next, we need the length of AC and BC. So length BC, using the distance formula, is equal to the square root of 2 squared plus 8 squared. So that's the difference in the x coordinates squared plus the difference in the y coordinates squared. And that equals the square root of 68. So I've left that in exact form, just like I did with angle theta. Notice that I did not evaluate this, so I'm going to leave it in that form. And length AC is equal to the square root of 10 squared plus 5 squared, and that equals the square root of 125. So the area of triangle ABC is equal to half times AC times BC times sine theta. And that equals half times the square root of 125 times the square root of 68 times sine of this expression here. And that evaluates to 45 square units. So the area of the shaded region is equal to the area of triangle ABC minus the area that we found in part 4, which was 18 square units. So that equals 45 minus 18, which equals 27. Therefore, the area of the shaded region is 27 square units.